Hello and welcome to this Naked Scientist Special Edition podcast. I'm Kate Lamble. I recently spoke to Emma Smith, a PhD student with the British Antarctic Survey, about her work detecting ice-quakes within glaciers while she was stationed in the icy north of Svalbard.
My PhD is based in Antarctica on the Rutherford ice stream, which is in West Antarctica, and I'm looking at microseismics that come from the base of that ice stream. So microseismics are like very small earthquakes, but in my case caused by ice moving against rock instead of by rock movement or tectonic plates. And what I'm looking at really is to see where these ice quakes are coming from, what could be causing them, and see what information we can get about ice movement and dynamics of ice streams in Antarctica.
So when we talk about ice streams, what do we mean?
An ice stream is a fast-moving outlet from an ice cap, or ice sheet, sorry, I should say, not ice cap. So Antarctica is covered by a big ice sheet, and it discharges most of the ice out into the ocean through these fast-flowing ice stream areas. And they often discharge into big ice shelves, which are the floating parts that you see around the edge of Antarctica.
And where in particular is the ice stream that you're looking at?
It's in West Antarctica, which is where all the British bases are, and it's at the south of the Antarctic Peninsula, which is the big bit that sticks up towards South America.
So when you're looking at how miniature earthquakes are created by ice moving against ice, how might these seismic events be caused?
So that's partly what I'm trying to look into, because we don't really know exactly what's going on. But in my case, what I'm looking at are events that we've termed ice-quakes that originate at the base of the ice. And we don't know if they're exactly in the ice or in the bed underneath or somewhere in between. But what we know is happening, certainly, is that there is interaction between the bed and the ice stream that's moving over the top of it. And we think it's probably this that's causing these ice-quakes.
So how are you measuring when an ice-quake takes place? You said that you're not sure where exactly in the ice it's happening. What measurement sensors are there to let you know that it is happening at all?
It's very similar to earthquake detection. What we've got is seismometers that we put on the surface of this ice stream. And they're effectively microphones, really, that record sound waves that are emitted as these ice quakes happen. So in the same way that when an earthquake happens, you can feel the ground vibrating, and that's due to sound waves travelling through the earth. In this case, we get sound waves that travel through the ice up to the surface where we can detect them on our seismic stations.
If you're figuring out when and how these ice quakes occur, what can that tell you about ice streams and about the Antarctic ice shelf in particular?
I think that's a very important point, really, and it's the motivation for our work is to understand more about what's going on, because Antarctica is such an important place in terms of the global climate and what could happen in the future. And what we're hoping really to determine from this work is more about how these particular ice streams within the bigger Antarctic ice sheet move and what it is that causes them to move faster or slower in terms of what's going on at the bottom of them, because really it's what happens at the base of these ice streams that governs how they move and how they discharge their mass into the oceans and into these ice shelves, which could eventually have some implication on models for how these ice sheets will react to climate change.
We've talked a lot about Antarctica, but you're not in Antarctica at the moment. You're at the other end of the world. Tell us a bit about where you are at the moment.
I'm just about as far away as you could probably get. I'm in the Arctic at the moment. I'm in Svalbard, and more specifically in Longyearbyen, which is a town of about 1,700 people, and it's about halfway up the main Svalbard island of Spitsbergen. And I'm up here at the moment doing a course at the university here, believe it or not, they have a university, and I'm doing a glaciology course here.
Why is Svalbard so important? I've only heard of it because it's the place where the polar bears live in the Northern Lights trilogy. Sort of what's up there apart from my imagined polar bear colony?
Well, originally, most of the things that are up here are to do with mining, but since then a lot of the mines have closed down, so people have moved up here to do scientific research, both on things like glaciers and also on ecologies and wildlife in the Arctic. And I think really it's important because it's quite an accessible place. You can see an awful lot within a day trip from the Longyearbyen town where I'm staying. So it's really quite a good place to come to study these kind of things.
So we've said that Svalbard is a really good place to go and look at ice. I can only imagine what the weather conditions must be like up there.
In the winter, which it is at the moment, it can be anything from just below freezing to about -30, -35. And it can be very, very windy, which it is today actually. So every time you go outside, you sometimes have to wear skiing goggles or something to protect your eyes just to stop all the snow blowing into your face.
And how does that temperature alter the field work that you're able to do?
The temperature doesn't affect it too much actually. It tends to be the other things like wind, which blow up all the snow and mean you can't see very far. It just means you have to wear quite a lot of specialist clothing and make sure you have all the bits of your skin covered so you don't suffer from frostbite.
And how about those polar bears? Are they a problem?
They are not as much of a problem as people might anticipate, but the precautions that you take are to carry around both flare guns and rifles with you wherever you go.
That's not something I imagine a geologist is normally familiar with.
No, not at all. We get specialist training when we come up here to make sure we all know what we're doing.
So what kind of field work are you doing at the moment?
In the last 2 weeks, we've been inside some glacier meltwater channels, which carve out big caves inside the glaciers, which are incredibly cool to go and look at. And they can be a bit of a squeeze to get into, but once you're into them, you're right down inside the glacier and you can see all sorts of channels and areas where water is carved out, almost like an underground river system.
So does walking inside these glacial river systems give you an idea about the ice-quakes you're looking at in your PhD work?
So it's quite a different type of system that they have up here in Svalbard. The glaciers are on a much smaller scale, so they tend to be a couple of 100 metres thick, whereas the ice stream I'm looking at is about 2.5 kilometres thick. However, a lot of the mechanisms that you can see happening here could well be applicable to things that are happening in my ice stream. And the great thing about being up here is you can go out and within an hour of the town you can really see these things happening, whereas in Antarctica it's not really possible to do that.
Now, you're off somewhere very exciting at the moment, but your normal PhD is based here in Cambridge. Sitting here in Cambridge, it's quite hard for me to imagine a glacial shelf 2.5 kilometres thick. How do you do that work here?
You're right, it's definitely hard to relate the two together, which is part of the reason I'm up here at the moment, having a look at some real glaciers in action, as it were. But my normal day-to-day life in Cambridge really is looking at data, this seismic data that was collected in the Antarctic, and trying to process the data into a form that we can use to locate these ice quakes, to look at the waveforms of them, and then try and relate that back to what we think might be happening.